class, this is Dr. McGonigal with another piece of your data analysis lecture. So in previous videos, we went over an introduction to SPSS, and then we went over data cleaning. So if you haven't watched those two videos, please stop this video and watch those before you watch this video. Today we're going to talk about descriptive statistics. So going back to our stages of data analysis, we have completed stage 1. We've opened a data file in SPSS and learned about what that file is about. We did number 2, which is cleaning our data and preparing to run our analyses. And so now we're on step 3, or stage 3, where we are running our descriptive statistics. This includes our means and standard deviations for numeric variables, and our frequencies and percentages for our categorical or nominal variables. Later on, we will get into what we call inferential statistics in stage 4. Descriptive statistics are used to describe our data. They answer questions about the levels of a variable that a participant has, percentage of participants that are in a certain category, and the frequencies of participants that are in a certain category. It's important to understand and describe our data before we draw inferences about our hypotheses, which we will do in stage 4, our inferential statistics. So let's talk about the types of descriptive statistics that we could possibly use. The first broad type is central tendency, and you should have learned about central tendency in your statistics class. This includes statistics such as the mean, or the average, the median, and the mode, or the most frequent observation. It includes variability, and that includes the range and the standard deviation. It also includes frequencies and percentages. So how do you know which types of descriptive statistics to use on a given variable? We have these 3 types: the central tendency, the variability, and the frequency and percentage. So in order to determine which are the appropriate types for your variable, you need to remember the distinction that we made earlier between categorical or nominal variables and numeric variables. So if you're confused about this, then stop this lecture and go back to the measurement lecture so you can learn more about the distinction between these. I'll just quickly summarize them here. Remember that categorical or nominal variables are variables for which numbers only have meaning that we assign to them. So for instance, if we were to assign a number 1 to gender and a number 1 to male and number 2 to female, then we have assigned those numbers 1 and 2 to our gender variable. It doesn't mean that females are higher than males on anything because the number 2 is higher than the number 1. So the numbers only have the meaning that we assign to them. On the other hand, we also have numeric variables, which include ordinal, interval, and range variables. These are variables for which numbers are inherently meaningful. In other words, if you have a numeric variable, higher numbers typically mean more of something. So in terms of participant age, for instance, we know that someone who's 38 is older than someone who's 37. The numbers there have inherent meaning. So which ones do we use for which descriptive statistics? The answer is that for categorical or nominal variables, where the numbers only have the meaning we assign to them, you want to use frequency and percentage for those in terms of descriptive statistics. On the other hand, for numeric variables, where numbers are inherently meaningful, you typically want to use means and standard deviations. Let's talk more about the measures of central tendency. Measures of central tendency tell us about the typical or most representative score in a sample. The mean, which we use the letter M, the uppercase letter M, italicized when we are reporting our means. This is the mathematical average, which is the sum of your numbers divided by the count of your numbers. For example, if I have 3 test scores a 51, a 49, and a 50. We add those up. The total would be 150. We divide by the count, which is 3, 1, 2, 3, and our mean is 50. Again, we use the mean with numeric data when our numbers are meaningful. We do not use the mean with categorical or nominal data. Take the example of gender. If we had 1 as male and 2 as female, and we added those together, we come up with 3, we divide by 1.5, we can clearly see that having the mean in that case doesn't give us any information. On the other hand, if you know that the mean of test scores is 50 and the numbers are 51, 49, and 50, the average score is meaningful in that case. So that might help you remember which types of descriptive statistics to use for which types of variables. In our data analysis in psychological research, we most typically use the mean rather than the median or the mode. Not always, but usually. So for this class, I would like you to focus on reporting the mean in your descriptive statistics. I'll just briefly cover the median and the mode to explain what they are, but you won't be using them further in this class. The median is the midpoint of a distribution, which divides it in half. So when you look at the median, you're looking at a score that's right in the middle. 50% of scores are above the median and 50% of scores are below the median. You can use the median with ordinal, interval, or ratio data. The mode is the most frequent score in a distribution, and the mode is the only measure of central tendency that's useful with nominal data. So for the example that I gave you earlier, how with gender and how we don't want to use the mean of gender, we could, however, use the mode of gender, right? So if we had scores of 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, we would say that 2 is the mode, or in other words, if 2 is female, female is the modal score for that distribution. Again, we won't be using that in this class. I'd like you to focus on the mean and to only use it with numeric data where numbers are meaningful. Now let's talk a little bit more about measures of variability. Why do we need to know about the variability? Well, it's important to know about that in addition to the central tendency because it tells us about the amount of spread or dispersion of scores in a distribution. There are different types of variability measures. The one that we're focusing on most in this class is called the standard deviation, abbreviated SD and italicized. So I'd like for you to report the standard deviations of the variables for which it is appropriate in your papers. However, I'll talk briefly about the range as well. So the range is the difference between the lowest and highest score in a distribution. So, for example, if the highest age in your distribution was 100 and the lowest age in your distribution was 20, your range would be 80. The standard deviation, on the other hand, and that's the one that we'll be covering most in this class, that you'll be working with most, is the square root of the average squared deviations around the mean. And again, you should have learned about this in your statistics class, but we'll briefly review it in case you've forgotten. The square root of the variance is also another way to describe the standard deviation. Keep in mind that the standard deviation is small when scores are similar to each other, and the standard deviation is large when scores are different from each other. So let's use an example that might help illustrate why the information about standard deviation is important and what measures of variability can tell us beyond what we know about the mean of a distribution. So let's take this example here. We have group 1 and we have group 2. And in each group we have 3 individuals, person 1, person 2, and person 3. So in group 1, you can see that person 1 scored 51, person 2 scored 49, and person 3 scored 50. Now we already talked about in our previous slide how the average or the mean score of this group 1 would be 50. because if you added these three scores up, you would get 150, and then you divide by 3 to get 50. So in group 1, is the number 50 a good understanding of what the average score is, or is that meaningful to us? Well, yes it is, because look at how close the scores are to 50. So 50 makes a lot of sense as the mean. Now, do you think that group 1 would have a high or a low standard deviation? In other words, are the scores largely similar to one another, or are they largely different from one another? The answer is that the scores in group 1 would have a very small standard deviation, very small amount of variance. Why? Because they're very similar to one another. Now let's take group 2. For group 2, our mean is also 50. However, person 1 scored 0, person 2 scored 100, and person 3 scored 50. So if we were to add these three up, we would get 150, and we divide by 3, so our mean score is 50. However, is 50 a really accurate representation of the scores of group 2? Well, not really, because it's not taking into account that somebody got a 0 and somebody got 100. In other words, the scores are largely different from one another. So in group 2, would you have a high or a low variance? A high or a low standard deviation, do you think? Well, if you said a high standard deviation or variance, you would be correct, because the scores are very different from one another. So this illustrates how two groups can have the same mean, but a very different standard deviation, and how that gives you very different information about each group. Now let's talk about getting descriptive statistics using SPSS software. So for means and standard deviations, you want to go into Analyze, and then you click on Descriptive Statistics, and then you click on Descriptives, the second one here. That's how you get your mean and your standard deviation. On the other hand, if you want to get frequencies and percentages, you click on Analyze, Descriptive Statistics, and Frequencies. So it's very similar for both. You're just choosing whether you're clicking on descriptives or frequencies to get either means and standard deviations or frequencies and percentages. So here's an example of frequencies. Again, we're going to analyze. We're clicking on descriptive statistics and we're clicking on frequencies. We are going to move the variable over from the left-hand column to the right-hand column. And then we're going to click OK. And here's an example of what your output would look like. In this first box here for frequencies, we see the number of cases or the number of participants that were used in our analysis. In this case, it's 48. And we're looking at the variable status. The second box contains our frequency table. So it gives you all of the labels that you have entered into SPSS or that already exist in SPSS for your variable. In this case, status is freshman, sophomore, junior, senior, or other. And then it gives you the number or the frequency of individuals that fall into each category. So there are 11 freshmen, 13 sophomores, 11 juniors, 11 seniors, and 2 that fall into the other category. The next column gives you the percentage. So about 23%, 22.9 for freshmen, 27.1 for sophomore, 22.9 for junior, 22.9 for senior, and 4.2 for other. Now, why did we use frequencies and percentages for our status variable? The answer to that is it's a categorical variable. So remember, with categorical or nominal variables, we use frequencies and percentages. Let's now go through an example of descriptive statistics. So in order to get here, we do the same thing. However, instead of selecting frequencies, we select descriptives. This is the output that you would receive when you clicked on descriptives and selected a variable. For this example, we chose days campus, and this variable is meaning how many days per week is the participant on campus on average. So this N first tells us the number of participants that were included in this analysis. The minimum tells us the minimum score for days on campus. So the minimum is 1. The maximum score is 7, which makes sense, right? Because you can't have more than 7 days per week on campus. And then we have what's of interest to us, which are the mean and the standard deviation. In this case, we can see that for these 48 individuals, the average number of days on campus is 4.56. So if we think about what that means from 1 to 7, 4.56 is on the higher end, right? It's above the midpoint of the scale. And our standard deviation, we want to round to 2 decimal places, so we would say 1.58 for our standard deviation. So to reiterate, in your papers for this class, in your paper 2, in your method section, you want to report participant characteristics such as gender, identity, sex, race, and age. So you want to report those percentages and frequencies or means and standard deviations. As we've gone over several times so far in this video, you want to only report percentages and frequencies for categorical or nominal variables and means and standard deviations for numeric variables. Here's an example of how you would report this in a method section. A total of 152 participants took part in this study. 49% of participants identified as male, N equals 74, and 51% of participants identified as female, N equals 78. The average age of participants was 34.82, standard deviation equals 6.26. A few things to point out when you're writing up this information in your method section. The first is that you want to italicize statistical abbreviations such as lowercase n, uppercase n, R, which is a symbol for correlation, T when you're using a t-test, which we'll learn about later, M for mean, and SD for standard deviation. Now, when do you use lowercase versus uppercase n? Maybe you learned this in your statistics class, but as a reminder, when you're talking about your full sample, you use uppercase N. When you're talking about a subpart of your sample, such as in this case, male participants and female participants, you use your lowercase n. In both cases, you want to italicize them. The second thing to consider is that when reporting numbers that are higher than 10, you want to use the number, not the word TEN, but the number 10, unless it comes at the beginning of a sentence. So you can see here that the number 49 came at the beginning of my second sentence in this section, but I have typed it out in terms of the words. I did not write the number 4 and the number 9. The third thing, like I've said before, is that you want to round to 2 decimal places when you are reporting your results. This may not be possible. For instance, when you're running your frequencies and percentages, it may not give you 2 decimal places. If that's the case, just provide what it gives you in your output. However, if it gives you 3 or more decimal places, then please round to 2 decimal places for your paper for this class.